Hi, and welcome to Meetings in Math. You are here for rotations of a figure on a coordinate plane. So a rotation is another transformation. Our essential question for today is, how can rotations be used to write the coordinates of an image? Today you are going to need your Jaguar Jots on section 2.4, essential question, how can rotations be used to write the coordinates of an image? A pen and a pencil is definitely going to be helpful today. Your perseverance and some self-confidence, because you've got this. So let's get started on rotations. First, let's start with some definitions. A rotation is a transformation that is a turn. So we're going to look at how we turn things today. A figure is rotated about a point called the center of rotation. The image has the same shape and size as the pre-image, and that is again because they are congruent. So we're still making congruent figures. The angle of rotation is the number of degrees the figure rotates, and we are going to look specifically at 90 and 180. Our worksheet has some 270 degrees on it, and we will talk about that. A figure can be rotated clockwise. So if you look at an analog clock and the way that the hands move this direction. Or counterclockwise, that means in the opposite direction. And so those are the definitions and some of the things that we need to know in order to start talking about rotations. So in order to do rotations, it helps to visualize the rotation. And we are going to do that with the help of our tracing paper or the parchment paper or any kind of paper that's a little bit see-through to help us move things around. So the figure below is rotated in a counterclockwise direction about the origin. So counterclockwise, that means it is going to go backwards. And we want to know the coordinates of the pre-image. Okay, so when we do this, we are going to use our patty paper to help us. And we are always going to mark our origin and make your X and your Y. So you want to know which way is X, which way is Y. And then I always also put arrows going in the positive direction. And then put in your corners. I always do my corners, and then this is A. The reason it's 90 degrees is every click is 90 degrees. So if we count by 90s, it goes 90, 180, 270, 360. I'm going to go ahead and write that right here. It goes 90, 180, 270, and 360. So those are our main clicks. So this is 1 click, 2 clicks, 3 clicks, and 4 clicks. That's how I talk about them. So we're going to put our pencil here just to hold it. So if you see that when we move it the first click, so that means when our axes line back up to other axes, do you see that our points line up again? So that would be 1 click. So that would be 90 degrees. When our axes line up again, that would be 180. So that would be our new figure A. When they line up again, that's at 270 degrees. That would be our new figure A. And when they line up again, that's 4 clicks. That would be our new figure, 360 degrees. Okay, so let's look at our vertices for object A. And I'm going to go ahead and make that blue. Purple, I'm sorry. It had a blue cap, but a purple pen. I don't know what's going on there. So we'll call this point W, point X, point Y, and point Z. So point W is the point 1, 1. Point X is the point 3, 1. Point Y is the point 3, 4. And point Z is the point 1, 4. So the pre-image is image A. So pre-image, remember, is the one you start with. So now let's look at our new image. So we want to look at image B. And we have to figure out which points went to which place. So let's bring back our see-through paper. So this is W, this is X, this is Y, and this is Z. And let's move it that 1 click. So this is y, this is x, this is w, and this is z. And so let's write that down. This is w prime. Let's give it a new color. Let's go with green. So this was w prime. Do you see x is up here? So this is x prime. This is y prime. And so this had to be z prime. So they twisted on us. And when we do rotations, they are going to do some twisting. So w became w prime, which is the point negative 1, 1. X prime to y prime and z prime. Okay. X prime became the point negative 1, 3. Y prime became the point negative 4, 3. And z prime became the point negative 4, 1. So there you have it. They turned. So we can also use our algebraic skills to do our rotations. So a clockwise rotation, remember, goes around this way, and a counterclockwise goes around this way. So a clockwise rotation, you would take, so that was what we just did, clockwise rotation, and you can see kind of how ours went, but with one negative 1, it makes it a little bit hard. So what we did was our x coordinate became our y coordinate, and then we took the opposite of the x coordinate. If we were going to do the counterclockwise, you would have done the opposite of the y coordinate and put that in the x place, and then the y coordinate became the x coordinate. It's a little bit confusing. A rotation of a 180 would have taken this and flipped it all the way around to here, but then also turned it upside down. So you would have taken the opposite of the x and the opposite of the y coordinate. A clockwise rotation of 270 and a counterclockwise of a rotation of 270, we're not really going to worry about those too much, but just in case you want to know them, you would have done the opposite of the y coordinate is the x, and then this one would have been y, and then the opposite of x. This one right here is the same as the counterclockwise of the 90, and this one right here is the same as the clockwise of the 90. That's why we don't really do them. We can accomplish the same movement with using 90 degrees. So now we have 3 problems that we're going to work on. And again, having that C3 paper is going to make it easier because we're going to do it through visualizations, not algebraic. So we're going to go 180 degrees about the origin. So the first thing I'm going to do is set up my axes. This is my x, this is my y. And then the next thing I'm going to do is I'm going to outline my shape, and I'm going to put dots, and then I'm going to call it A, B, C, and D. So it was D. Okay, so we know 180 degrees about the origin is 2 clicks. So hold it as best as you can and go 2 clicks. 1 click and 2 clicks. That's where it's going to end up, is in this quadrant. Now, something cool you can do is flip your paper over, get it out of that workspace, and you're going to outline your shape on the back side. Now the reason you're doing this is because what you did is you just made tracing paper. See how I left an outline already? So let's now redo those 2 clicks, 1 and 2. I know it ends up over here. I'm going to reline up my axes, and now I'm going to retrace those. And look what it did. It left a faint outline right there. So now I know that this dot right here, I can look back and it's A. The one down here is B. The one up here is C. And the one here is D. Based on the work I did algebraically, I know that that B has to have in the same realm of numbers. Let's start with A prime. So A is the point negative 6, 7. So that means A prime has to have those numbers in there somewhere. And you can see that it was over 6 and up 7. Let's go to B. B is the point negative 6, 1. Let's go ahead and figure out all these points. C is the point negative 4, negative 3. And D is the point negative 4, negative 9. So now from there, we can figure out all of our other points. So A is the point over 6 up 7. B is the point, or B prime is the point 6 and then 1. C prime is the point 4, 3, and D prime is the point 4, 9. And if you had a bigger coordinate plane, it'd be a little bit easier to see. So let's look at this one right here. And let's go ahead and name our points A, B, C, D, and E. So this says go 270 degrees counterclockwise about the origin. So clockwise is this way. So I want to go this way. I'm going to write on my paper which direction I want to go. So now I'm going to take my paper. Look, I'm just going to move over just a tiny bit. I don't need a ton of space for this. And I'm going to make my X, Y, and I'm just going to put in my dots this time. A, B, C, D, and E. I'm going to flip my paper over and I'm going to color in those dots so that I'm making my tracing paper. So I need to go the same way my arrow is going. And it's 270, so that's 3 clicks. So 3 clicks is every time it matches up. So 1, 2, 3. Because it was counterclockwise. So I end up right here. And now I'm going to, so A's here and B's here. And once I get going in the right direction, oh, my B didn't show up. So this is A prime and this one's B prime. And once I get going in the right direction, I know where I should be. A prime. So let's look at my original figure. And I'm just going to write down what the original coordinates were because that's going to help me do the new coordinates. So A was the point 6, -2. B was the point 9, -4. C was the point 8, -7. D was the point 5, -7. And E was the point 4, -4. So that's going to help me get my other points because it gives me a really good double check. So there's A prime, and here's B prime, and here is C prime, and here is D prime, and here is E prime. And so we connect those dots up to make the figure. So A prime is the point -2, -6. B prime is the point -4, -9. C prime is the point -7, -8. D prime is the point -7, -5. And E prime is the point -4, -4. These do take time just because there's a lot of steps involved. All right, let's look at the last one. This time we are going clockwise. Clockwise means as the clock goes. So we are going to go around this way. I am drawing it right on my graph. So let's go ahead and name those points. We'll name this one A, this one B, and this one C. Oh, I need to do the dots, don't I? Okay, so A, B, C. So here's A, here's B, here's C. So we're going 270. So remember that's 3 clicks. So 3 clicks because it's 270. So here's 1, here's 2, and here's 3. Line everything back up. Put your dots. So this is one's A and this one's B. So this would be your A prime and this one's your B prime, making the last one C prime. Okay, so let's write down what our original points were. A was the point 3, 6. B is the point 7, 6. And C is the point 5, 3. So A is the point, A prime is the point -6, 3. B prime is the point -6, 7. And C prime is the point -3, 5. Okay, so you've done these. So I do want you to understand, let's go back to this one right here. If I had done 90 degrees clockwise, that would have been the other direction. So here I was, and I done 90 degrees clockwise. Do you see we would have ended up in the exact same place? So 90 degrees clockwise and 270 degrees clockwise are exactly the same. Let's come back over to the triangle one. This one said 270 degrees clockwise. If I had done 270 degrees clockwise, I end up there. 90 degrees counterclockwise, I end up in the exact same place. That's why we don't tend to do the 270 degrees. We tend to focus on the 90 degrees. So I want you to come back up to the algebra, and I would like you to draw a line that goes from the clockwise 90 to the counterclockwise 270. They're the same. And I'd like you to draw a line that goes from the counterclockwise 90 to the clockwise 270. Those are the same movements. Thank you so much for showing up today. This is a really important one, and it's a little harder to grasp just because our brains don't tend to do rotations automatically. We see flips in real life and we see the translations in real life, but rotations is something we don't tend to deal with as much in real life. I would like you to explain rotations to an adult, a sibling, a stuffed animal, a pet, somebody, at least one time before we meet again. And thank you so much for joining us again, and I can't wait to see you in our next lesson. And remember, be kind to everybody out there because we all can use some extra kindness in our lives. Bye for now.